Now we're going to talk about quadratic functions. Just a very brief introduction. Quadratic functions are all mathematical expressions that are in the following way. Y equals a x squared plus c. The variable is squared, as you can see. A and c, as you may have imagined, belong to the real numbers. Remember linear functions video when I told you that y equals mx plus b, m is the slope, and if the slope is positive, that means that the function goes steeper, right, from the lower left to the upper right. But if the slope is negative, it means that the function goes from the upper left to the lower right. Well, something similar is going to happen with quadratic equations. If a is positive, it means that the function concavity is up. If a is negative, it means that the function's concavity is south. What is that term, concavity? Well, have you ever seen a satellite dish? That is something that has concavity, right? Satellite dishes are like this, or like a bowl, right? They're always facing north, right? Do you have direct TV or something like that? Well, that bowl has concavity facing up because the bowl is opening up to the north, to the sky, right? If the face or the dish would be facing down like this, then the concavity would be south. It would be pointing down, okay? So let's make a quick example. We have our axis right here. And let's say we have something like y equals x squared, the most basic quadratic function. A, as you can see, is positive 1. 1 times x squared is x squared, okay? That means the concavity is going to be up. The function is going to be opening north, all right? Graph looks a little bit like this. And you can do the little exercise of doing the values to it. It's going to look a little bit like that. This is y equals x squared. Now let's do another example. What happens if we have y equals minus 2 x squared? Well, in this case, a is minus 2. Remember what I told you on linear functions? That the higher the slope, the steeper the linear function is. Well, in this case, something similar happens. The higher or the lower the degree that a has, the closer the function is going to express its concavity, okay? So if we have y equals minus 2x squared, that means that it's going to be a little bit more closed, okay? Let's do the positive one just for the sake of example and comparing it against x squared first. 2x squared, it's going to look a little bit like this. And if we do minus 2x squared, it's going to look a little bit like this. Okay? As you can see, the higher the value, the more it closes. Okay? Now you may ask, how do you come up with these functions? How is that able to graph that easy? Well, it's really simple. All you have to do is throw in a couple of values, and then the rest are going to fall automatically. Okay? Now we can do that real simple with a quick example, just like we did with the linear functions. What happens if we have x and, say, x squared? Or y? Well, if x is 0, right here, 0 squared is 0. 0 times 0 is 0. If x is 1, well, 1 squared, 1 times 1 is 1. If x is 2, 2 squared is 4. If x is minus 2, minus 2 times minus 2, or minus 2 squared, is 4. If x is 3, 3 times 3, or 3 squared, is 9. Minus 3, minus 3 times minus 3 is 9 as well. So as you can see, it doesn't matter what value you introduce in x, y, or fx squared is always going to be positive. Why do you think is that possible? Well, it's very simple. It doesn't matter what value you introduce in a square, the result of a square is always going to be a positive value. Always. Okay? Now, what happens if you have our second example? 2x squared. Well, if we have 0, x equals 0, y is 0, right? 0 times 0, 0. And everything else is 0. 1. 1 squared is 1 times 2, 2. 2. 2 squared, 2. 4 times 2, 8. Minus 2. Minus 2 squared, 4 times 2, 8. Three square, 9 times 2, 18. Minus 3 square, 9 times 2, 18. So as you can see, the function exactly behaves pretty much the same way that the past one, only that it increases a little bit more aggressively. Alright, if we compare this to the past function, and we can even do that, you will see how the behavior, the pattern with the values is pretty similar. The only difference is the degree of aggressiveness that they have. Well, the first one that we have was x squared. We can do that right here. 2x squared and minus 2x squared. But the first one was 0, 1, 4, 4, 9, 9. And we had 0, 2, 8, 8, 18, 18. Alright, let's do the third one, minus 2 squared. It's going to be the same, only that it's multiplied by minus 2. 0, 0, 1, 1, minus 2, 2, 2 squared, 4, minus 2, minus 8, minus 2 squared, 4 times minus 2, minus 8, exactly the same. Minus 18, minus 18. So all you have to realize is the pattern that is happening with the numbers. As more values you introduce, and the higher that you introduce on x squared, the function is going to keep growing. If I do 4, 4 squared is 16. If I do minus 4 squared is 16 positive. If I do 4 on this one, it's going to be 16 times 2, 32. And so on. 4 right here is going to be minus 32, and so on. See, all you have to figure is the pattern with the numbers. It doesn't matter what values I introduce right here, 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 or here. The function is going to behave in the same way because it's following a pattern. In mathematics, almost all functions follow a pattern, especially these basic ones.